Here we're looking at example 5, but before we get into that, we have to first discuss what are the vertices of a graph of inequalities. The vertices are pretty much anywhere that you see an intersection with your inequalities. And how we actually find them is we can actually just look at the graph and see where they're at. Or, if you remember back from our 3-1, 3-2 set of notes, you could algebraically prove where they were crossing by using the elimination or substitution method. So, or elimination / substitution method to prove where they cross. And these vertices actually have a profound impact. In fact, we'll be talking about that when we start getting into linear programming, which is the next section. All right, so vertices are really, really important in terms of the applications that we'll soon be looking at. And as a result, right now we're just going to kind of look and see as a preview how to find them and where they're located and things like that. So for the first one, we have x is larger than 0. So we'll just say that he is going to be our red graph. X being larger than 0. Well, we notice that we just have this x variable is larger than some number. And as a result, on our x-axis, we're literally going to graph 0. Well, here he is. Now, since there's no y can literally be anything. Okay? Again, we've talked about that with standard form in the past chapter. But since there's no bar underneath, we have a dotted line here at x equals 0. Now we have to test a point off of our line. So for example, we could test 1, 0. Is 1 larger than 0? The answer to that is yes, it most absolutely is. So we would shade then towards that point that we just tested since it was true. So all of these other points then would also be true. Now going ahead and going to our green line, we have y is larger than 0, placing a point at 0 on our y-axis. There's no x, so x can be anything. And we also have a dotted line because there's no bar underneath. Now we want to test a point that is off of our line. In this case, maybe we could go with like the point 0, 3. So is 3 larger than 0? The answer to that is yeah, it absolutely is. So we tried 0, 3, it worked. That means all of these other points would work as well. Now we have this third inequality that we have to graph. Well, we notice that's in y equals an mx plus b type form, so we're going to go ahead and plot our y-intercept, 0, 8, and then use our slope -2, so down 2 over 1. Down 2 over 1. We also notice that we have a solid bar underneath, so we're going to have a solid line. Testing a number, we're going to choose maybe, we notice that the origin is clearly below that line, so we can use the origin there. Is 0 less than or equal to -2 times 0 plus 8? Well, we'd end up then with 0 being less than or equal to 0 plus 8. So is 0 less than or equal to 8? It most certainly is. So because we tried 0, 0, it worked. That means all of these other points would work as well. And as a result, when we're looking for our final shaded region, we notice that it's inside of this triangle right here. Where they all three overlap. Now, looking at the vertices, in terms of the graph, we can actually just see specifically where they're at. So for example, right here, we see an intersection between our blue line and our red line. And that point happens to be at 0, 8. So for our vertices, we have the point 0, 8. There's another intersection that we see here at the red line and the green line. That happens to be our origin, so that is 0, 0. And then our last one, we notice another intersection happening between our blue and our green line, happening at 4, 0. And so these then would become our vertices. Now, not all the time will you be able to just see what they are, but for example 5, as a starter one, we were able to just identify it just by looking at the graph. But again, that is example 5 from our 3-3 set of notes.